This video is on the derivatives of exponentials and logs. So if we have a function of e to the power of x, the derivative is just e to the power of x. And if our function is ln x, then the derivative is 1 over x. Just a few examples here to show how they work with the different rules that you should have already done with the chain rule, product rule and quotient rule. So first example, the function equals 5e to the x plus 2 ln x. So with these, just a plus in the middle, so we do the derivative of each separately. So the derivative of x will just be 5e to the x, because e to the x doesn't change, plus 2 times 1 on x. And then we can just simplify that down to 5e to the x plus 2 on x. B, g of x equals e to the power of 2x. Now we have something in the power next to the x with the e, we need to do a chain rule. So I'm going to do the long way. You will get quicker at doing this in one step, but to start with, I'll show you how it works with the chain rule. So our u will be the inside part, which is 2x, then the y will be e to the power of u. Our derivative of u will just be 2, and our derivative of e to the u is just e to the u. Then with the chain rule, we multiply those two together. So we'll have 2e to the u. We just put u back in, so it'll be 2e to the 2x. So you can see there the derivative of the power is 2, that comes out the front, and then e to the 2x just stays the same. C, e to the x multiplied by ln x. We have something with x multiplied by something else with x, which means it's a product rule. So our u is the first function, and our v is the second function. The derivative of each, e to the x is just e to the x, derivative of ln x is just 1 on x. Then we just apply the product rule. So derivative of u times v, so we'll have e to the x ln x plus u times the derivative of v. So e to the x multiplied by 1 on x. Here we can simplify this if you need to, and we can factor out e to the x. The factorising out isn't always necessary, but sometimes it can help simplify a question in and on calculator to be able to complete the next steps that are needed. Part D, see here we've got e to the x divided by ln x, which will be a quotient rule. So u equals e to the x, and once again v equals ln x. V is always a denominator. Our derivative of each, and then we can apply the quotient rule, which is u dash v, so e to the x ln x minus v dash u, so e to the x multiplied by 1 on x, then all that is divided by v squared, so ln x all squared. And then once again we can factorise out e to the x on the numerator if we wanted to simplify it, if that was going to help us with another part of a question. But it is not always necessary. And that is the derivatives of exponentials and logs.